Let's consider two simple cases where we have only heat or only work being transferred from one place to another. From there, we'll be able to take a look at our sign conventions, make sure everything is consistent in our minds, and then talk a little bit about what happens if we have both heat and work occurring at the same time. Now, if only heat is being transferred, let's use this as our thought experiment. We're going to have our system be a chunk of cold metal. Our surroundings are going to be hot water. And I'll also specify that we hurried up and immersed that cold metal before we started doing any measurements. And so on the time scale that we're actually watching for, there was no work being done. We didn't have to push any water out of the way. That all happened before the experiment began. Now in that case that I've just described, we're going to have delta E be positive for the metal because the heat is flowing from the hot water into the cold metal. The cold metal is gaining in energy, and because it's gaining, it's going to be a positive sign. It's going to be greater than 0 as the heat flows into our system. Now, we can contrast that to the case where we have only work being done. Now, for this one, I'm going to say that we have dry ice, and it's going to be just below the sublimation point. So it's going to be cold enough that it's staying solid, but only barely. And we're going to have carbon dioxide gas around it that's at about the same temperature. So we don't have any changes in temperature occurring, and even then, the entire system is going to be at a uniform average temperature. We're going to have it be an insulated piston for the surroundings, so no heat's being transferred in and out of our system. So the average energy is going to, average heat energy is going to stay the same the whole time. This means that the only thing we have happening is going to be work. Now we know that dry ice is solid carbon dioxide, so those molecules are packed in closely together. When they sublimate, they go into the gas phase, and now there's lots of space in between them. So in that case, I'm going to start taking up more space. The piston is going to have to rise. So for my system, the system has its volume increasing. But notice, it's hard sometimes to think about what's going on as far as work, but when we think about it this granularly, we can see that the surroundings are getting pushed away. That means energy is being done by our system to the outside world. Now, in that case, we have 0 change in energy for heat. Work is being done on your surroundings. When work's done to the surroundings, that means energy is actually leaving your system because you're shoving these molecules out of the way. You had to put energy into the surroundings to move it away. That's kind of counterintuitive if you're thinking of it in other ways. If you're thinking of it very contextually, the way I just described it, you'll be in good shape remembering what work sign conventions will be. Now, let me also point this out. We had things really closely spaced. When they popped apart, they lost energy that was holding them all together, right? We actually went from a really orderly system to a really disorderly system. And that change in entropy, that's actually the term that we use in science for disorder, the change in entropy actually meant that we were losing energy. We became more disordered, that's more stable, we gave that energy to the outside world. Delta E for our surroundings is going to be increasing. And then for our system, it's going to be less than 0. We're losing the order, we're taking up more space, we're pushing the outside world out of the way, and as a result, we did work on the outside world. Okay, now, if we have both heat and work occurring, the signs could be anything, and it becomes very hard for us to gauge. We'd actually need to know the magnitudes as well. Now, if I told you that I did, 50 joules of work on the outside world and heated the system by 30, now we can actually start deciding which direction things are going to go, and we can interpret all those signs and magnitudes simultaneously. But if all we know are the signs, we can't decide what the final outcome is going to be when both heat and work are done. We need more information. Now, here's our quick reminder of that. So for heat, if we do work to the system, it's going to be a positive sign. If we do work to the surroundings, now if we heat the surroundings, if it's heating the surroundings, heat energy is going to the surroundings. Now for work, if we do work to the system, Like if we press down on this piston, we're doing it to the system, we're putting energy into the system, positive charge. If we allow it to do work to the surroundings, pushing the surroundings away, that's going to be a negative sign, as it's pushing the surroundings away. Those are ways that you can remember the sign conventions for heat and for work.